Hi everyone, so welcome to the first video in the rate of reaction series, and I thought in this first video it'd be important and useful to look at some of the knowledge that you require in terms of how we represent reactions as scientists, as chemists, and also what has to happen within that reaction mixture in order for a reaction to happen in the first place. This is all kind of prerequisite knowledge that you need in order to understand kind of the rest of the topic, really. So it's a good place to start. So let's have a quick look at kind of put into context the way scientists write out how reactions happen, if you like. So let's take an everyday example of a chemical reaction that you'll all be familiar with from your food lessons. In fact, you'll have all made a cake in your food lessons. Maybe not like a Victoria sponge. I don't know if this is one actually, but certainly a sponge cake. Maybe not one that big, but certainly you have mixed together ingredients and then you put it in the oven, and then at the end you have a cake, hopefully looking like that. And you would say that the ingredients that you are using is your flour, butter, egg, sugar, etc. And what you make is the cake there. But in science, in chemistry, we would call the things that we are mixing together, they're our reactants. This is a chemical reaction because we are mixing together some substances and they are changing, and the bonds within those substances are breaking to rearrange the atoms within those substances to form a new product, a new substance. And we call that a product. In this case, it is cake. So we've got reactants on the left-hand side there, and they're turning into products. Now, if you were to write this as an equation as a scientist, instead we'd write plus signs between all those reactants, and you draw a big arrow to say that's turning into your product. So it would look like this. We've got flour plus egg plus butter plus sugar plus baking powder. Arrow makes a cake after they've reacted together, and they need the oven in order to react, because we need to provide some energy in order to break the bonds within those substances so they can reform bonds in the cake. Okay, so let's take this example then and look at a more kind of typical chemistry example, and that is the reaction between baking powder and vinegar. Okay, so when you mix baking powder and vinegar, again, I imagine many of you kind of made volcanoes in primary school or have done it at home, and to make your volcano erupt, you mix these two substances with probably some red colouring, and it fizzes and it bubbles over and it gives you that kind of lava flow. And the reason why it fizzes is because carbon dioxide is made as one of the products in this reaction, and you see that fizzing if you were to react them together. Now the reactants here are vinegar and baking powder or baking soda, but their chemical terms are ethanoic acid and sodium carbonate. And as chemists, when we write out this reaction, we'd use those terms instead. And what we make from that reaction is water and carbon dioxide. You can obviously see that carbon dioxide being given off as a gas, but you also make something called sodium ethanoate, which is dissolved in the water. You don't see it unless you were to boil off the water afterwards, but it's certainly made there. And we can write out this equation, writing the reactants on the left-hand side there, then we write an arrow, and we write the products on the right-hand side. And in this case, we have more than one product. With the cake, we had one product, but here we have more than one product, so we put plus signs in between those as well. So here on the left-hand side, we have our reactants, the things that are reacting together. And here on the right-hand side, we have our products. Those are the things that are being made in this reaction. And the bonds in the reactants are being broken. And for this to be a chemical reaction, we have to form new substances where new bonds have been made. And so those chemical bonds have been made to make these new substances. Okay, let's have a look at a closer look at what has to happen then at a particle level. So as you'll have learned in Key Stage 3, all substances are made of particles, solids, liquids and gases. And the particles in the substances that we're mixing together here won't look like what I'm about to show you, but it'd be very difficult to represent what might happen if I didn't draw them like this. So obviously these particles have spaces between them. This really represents a gas, but let's pretend that these are the particles in the vinegar and the sodium carbonate, the ethanoic acid, sorry, and the sodium carbonate that we're mixing together here, the baking soda and the vinegar. Now at all times these particles are moving around and therefore bumping into each other. And as scientists, we call those bumps collisions. So they're always moving around and colliding into each other. And only some of those collisions will happen hard enough for bonds to be broken in those particles, in those substances, and then for new bonds to be formed. And in the energy changes topic, we learned about what that force of collision is called, and we call it the activation energy, the amount of energy that's required within that collision in order for the particles to react. And we can draw it like this. So particles have to collide first in order to react, but they have to collide with enough energy or with enough force. Now, those two things aren't the same thing in terms of physics, but we can use both those terms, and it makes sense in this context. And so your reaction profile here shows you that unless our reactants collide and get to this level of energy, they will not have enough energy to break the bonds required in order then to fall down and break new bonds to make these products. We call this the activation energy. That's the amount of energy required in order for a reaction to happen between two particles. And for a reaction to happen, particles have to collide with enough force or with enough energy. Of course, two reactant particles have to collide. If these two particles collide, then nothing will happen. And indeed, if two particles collide with not enough energy, then they'll just bounce off each other and nothing will happen. Okay, so just to recap, please pause the video and see if you can answer these questions from what I've just said. Okay, so let's just quickly go through them. So what is a chemical reaction? That's when chemical bonds between atoms are broken and made so that atoms get rearranged into new substances. So the whole idea here is that a chemical reaction is where new chemical bonds are formed so that we get new substances from those reactants. What are the reactants in a chemical reaction? They're the starting substances. The bonds are broken in these and they turn into new substances. The products in a chemical reaction, those are the new substances you end with that have been made. Those bonds have been made during the reaction in that new substance. And then what do you write on the left-hand side of an equation? We write the reactants, the names, or the symbols of those reactants. So we didn't talk about symbol equation in this video, we just talked about names, but of course you probably know that scientists would write these equations with symbols rather than names quite often. When writing a reaction as an equation, what you write on the right-hand side is the names or the symbols of the products. And then finally, what must the reactant particles do in order to turn into product particles? They must collide with enough energy. If you wrote enough force, then that is also okay. Okay, thanks very much for listening, and I'll see you in the next video.